is something that I think Ms. Martin usually does in Math 3. Technically, composing functions is not really in Math 3. You just have to be able to add, subtract, multiply, and divide with functions. I think she usually throws it in there so you have some exposure to this before you get up here. Plus, it also shows up on like the ACT and stuff, so it's a good thing for her to include a little bit earlier. But we're going to go back over it and possibly in a little bit more depth. One thing that we will definitely do that I'm not sure if you guys do much in Math 3 is we will look at it with multiple representations. So sometimes we will have an equation, but sometimes we will have a graph or a table or even a written expression of the function. So that might be a little bit different from what you've seen. So this first part is definitely review. If I see f of 5, that means I'm plugging in 5 for the x, right? So this should be something we're pretty familiar with. We're taking the 5, we're plugging it in right here for this x. We will get 2 times 5 minus 3, which is 10 minus 3. So 7 is our answer for that. However, it is not only numbers that we can plug in. So we could also be asked to do something like f of 5x minus 1. And if that's the case, the principle still holds the same. You are taking whatever is in that parentheses and you are plugging it in for the x in the f function. So that would look like this. 2 parentheses 5x minus 1, close your parentheses, minus 3. So wherever that x was, we're replacing it with a 5x minus 1. It's important to put those parentheses there so that you distribute appropriately if necessary. They're probably not going to leave this way. They probably will simplify it. So you'll get 10x minus 2 minus 3, which would give us 10x minus 5. You can't go any further than that because they did not give you a value for your x on that one. So that it's not an equation because, I mean, this is just equal to f of 5x minus 1. So there's nothing over here on the other side of the equal sign. So we can't we can't do anything else for that. Okay, so example 1 here sort of leads us through a composition of functions without writing it like a composition of functions. So for this it says g of x equals 3x plus 1. It says let g of 2 equal c, find g of c. Okay, so what would we need to find first? G of 2. We have to plug in 2 right here for our x. So g of 2 is 3 times 2 plus 1. That's going to be 6 plus 1. So g of 2 equals 7. Right, g of 2 is just a label there telling us that we plugged 2 into g. So what does our c value equal? It equals 7, right? Because g of 2 is c. So then it asks us to find g of c, which is, of course, just g of 7. So we plug 7 in. So we got 3 times 7 plus 1. And that is going to be 21 plus 1, which will give us 22 for our final answer. Okay, that essentially was a composition of functions. It just wasn't written with the notation that we usually see with the composition of functions. Because we found g of 2, and then we took that value and found g of that value. Right? So what we really did there is we did g of 2 for that. So composition of functions has 2 different accepted notations that can be used. I prefer this first one, which is f of g of x with parentheses. So this is telling you that you're taking g of x right here. So g of x is right here, and you're plugging it into the f of x function. Right? The other way that they also write this is the fog notation. They use that little open circle right there. So they do f of, this also means f of g of x. Whatever letter is closest to the x is what's getting plugged into the other equation. They might use either one of these types of notations, but when I see this, I just picture it as f of g of x and think of it that way. It is important to note that composition of functions is not commutative. What does commutative mean? It's a property you learn like in elementary school. It does not work both ways. Addition is commutative. 2 plus 3 is the same thing as 3 plus 2. Subtraction is not commutative. 2 minus 3 is not the same as 3 minus 2 for that. So f of g of x is not usually equal to g of f of x. There are some instances where it might be, particularly if f and g are inverses of each other, but in general, these are not commutative. So, Mr. Passwater's got us an example here to show that that's not the case. So, if I am given f of x equals 3x minus 5 and g of x equals 2x plus 1, then he's asked me for f of g of 3 and g of f of 3. So when I see f of g of 3, I need to find what's on the inside first. So I'm going to do g of 3, which will be 2 times 3 plus 1. That's going to give me 7. And then I'm taking that and replacing my g of 3. So my next step would be to do f of 7. And f of 7 would be 3 times 7 minus 5. So that would be 21 minus 5, which is going to give us 16. So 16 would be your answer there. Okay, questions there? Okay. On the next one, we would have to do f of 3 first. So I would do f of 3 would be 3 times 3 minus 5. That's going to be 9 minus 5, which is going to give us 4. And then we're taking that value and we're replacing our f of 3. So then we'd be doing g of 4. And so g of 4 would be 2 times 4 plus 1. And that's going to be 8 plus 1, which will give us 9. So 9 would be our answer. So f of g of 3 was 16, but g of f of 3 was 9. Right. These two are definitely not commutative. Okay. You can also compose a function with itself. You don't have to have two different functions. So like for C, this is asking us to do f of 2. So again, you're doing that, the part closest to the 2, you're doing that first. You're doing f of 2. So we would find f of 2, which would be 3 times 2 minus 5, which is going to give us 1. And then we take that and plug it in for our f of 2. So we do f of 1, which would be 3 times 1 minus 5. And that's going to give us negative 2. Okay, questions? Did you guys do this in Math 3? Think so? Is a chance? Did you have Miss Martin or did you have? Oh, you might not have. Can't speak for what happened. And I have a general idea of what Miss Martin does. No one knows exactly what Coach Wood did in there. I don't think Coach Wood knew until the day he showed up and did whatever was happening there. And if he didn't teach it, he wasn't wrong by doing that because it's not in Math 3. You don't have to teach it in Math 3. So you also can compose functions without plugging in numbers. So this is asking us to use those same equations. I'm going to rewrite them down here because when I scroll down it goes away. So f of x is still 3x minus 5, and g of x is still 2x plus 1. So we could be asked to find f of g of x, which means that we're taking g of x and plugging it into our f function. So that would look like this. We're taking 2x plus 1 and we're plugging it in over here where the x is at. So we would have 3 times 2x plus 1 minus 5. Somebody in second period suggested we write it this way, f of 2x plus 1, which would be fine because g is 2x plus 1. So what we're doing is we're plugging in 2x plus 1 for the x. And so they're usually not going to leave the answer like this. They'll usually simplify as much as they can. So that would be 6x plus 3 minus 5, which would be 6x minus 2. So that is our f of g of x function. For g of f of x, whatever is closest to the x is what's getting plugged in first. If you want to, you could think of this is g of, you're plugging f in. You could write 3x minus 5 if you want. You don't have to write that necessarily. But you're plugging 3x minus 5 in for your x here in your g function. So 2 times 3x minus 5 plus 1 would look like this. And you'll get 6x minus 10 plus 1. And that is 6x minus 9. There. So notice that for those, we're getting different equations, which again shows us that those two are not commutative. We cannot say f of g of x equals g of f of x. For the sake of time, I'm not going to do all of the examples that Mr. Passwater has here. For example 4, he gives you 3 different functions. I really just want to look at part C here. I think you guys are probably pretty good with A and B where you're plugging in a number. But C asks for K of M of X. So that would mean we're taking M of X, which is right here, and we're plugging it in for X in our K function. This function has 2 x's, so you got to plug it in 2 places. So K of M of X is going to be 3x plus 2 squared plus 4 times 3x plus 2 plus 5. Now, where most kids mess up here is in this first part. Most kids want to say that 3x plus 2 squared is 9x squared plus 4. And it is not 9x squared plus 4, right? Anybody know what we do get there? Do it in your head. Okay. I would like for you guys to be able to do it in your head. If you cannot, you can write it to the side, 3x plus 2 times 3x plus 2. So you have to distribute this out. You will get a 9x squared, but you will also get plus 6x plus 6x plus 4 there, which would be 9x squared plus 12x plus 4. Now, when I do this, I do it in my head. I do not write it out. The shortcut that I use, the little saying I use for it, is that I'm going to square double square, because I'm going to square the first term. 3x squared gives me 9x squared. For that middle term, I'm going to multiply 3x and 2 together. That's going to give me 6x. And I'm going to double it, which gives me the 12x. And if you look at the structure here, it's because those middle two, to get them, you multiply the 2 things together. And there's always 2 of them, so you double it, right? That's why it works. And then I square the last to get that 4. So I'd like for you to work towards just being able to do that in your head without having to write it out, but of course I would rather you be correct than fast. So if you need to, write it out to the side. Then we would also distribute that 4, so we'd get plus 12x plus 8, and then we got that plus 5 over there on the end. And we would combine our like terms, so we'd get 9x squared plus 24x, and I've got 4 plus 8 plus 5, which is going to give me plus 17. So that would be my answer there. Okay, questions? All right, let's look at one with a graph, because this really starts to get into more pre-calculus territory here when they're asking us to do this from graphs and tables and functions and all of those different things, because it's one thing they really try to focus on in the AP curriculum. So, and it's a good thing. So they tell us the function h is defined by h of x equals g of f of x, or they just use the other notation here, g of f of x. Find the value of h of 6 as a decimal approximation or indicate that it is not defined. So when they're asking for h of 6, they're telling you that you're plugging 6 into the equation, and the equation is g of f of x. So h of 6 is just g of f of 6. So we're going to have to do f of 6 first. That's on the inside. F is the graph. So to find a value from a graph, we're going to go, our x coordinate is 6. So we're going to go to where x equals 6. And we're going to look up and down till we find the point where our graph has an x coordinate of 6. Then, to find f of 6, f of something is the y coordinate that goes with that. So we need to look over here to the y-axis, and that value right there is our f of 6. Okay, so our f of 6 would be 1. So I've got g of 1 is what we're doing there. So if you're ever finding like f of a number from a graph, you find the point where the x coordinate equals that, and it is your y coordinate for that. And then g of 1, that's an equation. We're just going to plug in 1 into that equation. So we will have 1.2 times 1 to the third minus 4.7 times 1 plus 9.62. And it's probably going to be calculator active. I mean, it's not too bad without it, but let's just use the calculator. When you type that in, you're going to get 6.12. Okay, questions? All right, here, Mr. Passwater really goes all out on this. We've got a graph for f, we've got a table for g, we've got a piecewise equation for h, which we probably haven't seen in a little while, and then k, which I almost missed until I did a few of these problems. K gives you a written explanation out in words of what's happening for k. So let's look at what we would do for some of these. So let's do A right here, f of g of 7. So you always want to find whatever's on the inside first. So if I'm looking at g of 7, I need to look at the table because that gives me my values for g. I'm going to go to where my x coordinate is 7, that's right here, and g of 7 is going to be the g of x or the y coordinate that goes with it, that's 4. So this is going to be equal to f of 4. F of 4 is going to be found from my graph up here. So 4 is right here. We're looking for that point on the graph where our x-coordinate is 4. And then where do I look to find the value of f of 4? or what would it be? It's going to be negative 1. You're going to look over here at the y-axis, and negative 1 is your answer for that. Let's skip over to C. I don't want to do all these because I want a little extra time. I've got h of k of 0 for this. Now k, they gave me a written explanation. So what I've really got to do for k first is I've got to write an equation for k. K is a quadratic function with a horizontal translation of 2 followed by a vertical translation of 3. When I have a horizontal translation of 2, what am I going to have to do on the inside of the parentheses? Opposite, so it's going to be x minus 2. I'm going to have a square right here because it tells me this is a quadratic function, which means that I've got an x squared in it. And then I also have a vertical translation of negative 3. What should I do on the outside? I'm going to minus 3, subtract 3 right there. So I sort of had to write my own equation there. I'm going to have to plug 0 into k first. So k of 0 is going to be 0 minus 2 squared minus 3, which is going to be 4 minus 3. That's going to give me 1 there. So I'm doing h of 1. H is my piecewise function. So on a piecewise function, you have to think about the number that you're plugging in. So the number that I'm plugging in here is this 1. So I'm looking at h. The first thing you want to do is you want to decide which piece of the function you want to use. In a piecewise function, you only use one piece. So is x less than 1, equal to 1, or greater than 1? It is equal to 1 because I'm plugging in 1 right here. So I want to use this line. So that means I would take 1 and plug it into that equation, but do I even have an x here where I could plug that in? I do not, right? So my answer for that is just negative 4. It's going to be negative 4 for any number that you plug in. Now, in this particular case, 1's the only number you can plug in, but you don't actually plug it in because there's not an x there. Let's see. I'm going to change E because I want us to do another one with that piecewise function, but it would only have you plug it in 1 again, and I want you to see what happens to a piecewise when you plug in a different number. Let's change that one and make it H of G of 1. So if I'm finding G of 1 first, so I need to find G of 1 right here. I am looking at my G function. Oh, shoot, no. Let's make it G of negative 1. Make it G of negative 1 so that we can do it. We could not do what I had there because there is no x coordinate of 1 right there. So what is G of negative 1? It is 3 because you're looking at where the x coordinate is negative 1 and you're going down here and choosing the y coordinate. So G of negative 1 is 3, which means we need to do H of 3. So if I'm doing H of 3 over here, then for H of 3, I need to decide which piece of the piecewise function to use. Should I use the top, the middle, or the bottom? I'm going to use the bottom because 3 is greater than 1. So I'm using this, right? And so I'm going to plug in 3 for the x in that function, and I will just get negative 3 right there as my answer. Okay, questions? All right, for our last one, let's look at 7. Here, for 7, I've got this table. This table has values of f and g. And it tells us that h of x equals f of g of x. And it wants to know what h of 1 is, which means we're really doing f of g of 1. So for that one, I would have to do my g of 1 first. Okay? What is g of 1? Is not negative 2. It is 0. So what you want to do for this is 1 is your x value here. So you're going to the x line right here, and you're going to where x equals 1. And then you are going to, you need to go to the g line. So like in this first part, you're not using f at all in that first part because you're not doing f yet. And you're going to choose 0 right there. So that would mean that we're doing f of 0. Now, for the second part, let me erase all my stuff here. For the second part, now I don't care about g, right? I'm not going to use that line at all. I want f of 0. What is f of 0? What? It is negative 1, because I'm looking where my x coordinate is 0, and it's going to be the y coordinate on the f line that I use here, so I will get negative 1 for that. Sometimes those tables can get a little confusing whenever you're looking at, when they put f and g in the same one. Okay, you guys already have the worksheet because I passed all that out in case we were not here. But what I want you to do before you go, and this will probably take you till about time to go, is I have made an exit ticket, and I actually moved it. I moved the due date to Monday because second period ran out of time, but we're going to go ahead and do it now because it's better as a exit ticket. So if you will go to Canvas, there is a 3-question little quiz. Now, I do not have this sync into the grade book. It does not count. I mean, like, it's going to grade it for you so that I can see how you did. But it is not going to count as a grade at all. It's just for me to see how you're doing. Oh, wait. Hold on.
It says 2.5. It's 2.4 stars.
Yeah, 2.4 will be on the quiz. The reason I didn't put on the exit ticket is because I was really just wanting to sort of check what we've done in our remote days here. So, finally got in. All right, so if you guys will all go and do that exit ticket for me when you get done, you are welcome to pack up. I believe I said there. I believe I said the first, let me see here. The first one is calculator active, so you can use Desmos on that first one. I want you to try to do the next 2 without Desmos.